Now after dividing the two polynomials all together, let's just move on to our next concept, which is called as the remainder theorem. What is the remainder theorem? So the remainder theorem says that let Px be any polynomial of the degree greater than or equal to 1 and let A be any real number. So if Px is divided by the linear polynomial x minus of A, then the remainder is P of A. This is actually called as the remainder theorem. So always remember, if Px is nothing but any polynomial and Px is divided by any linear polynomial x minus of A, then their remainder should always be of the type P of A. Now let's just see the remainder theorem with the help of an example. So let us suppose we are taking the example number 1 or the question number 1 as find the remainder when x raised to the power 4 plus x cube minus 3x square plus x plus 1 is divided by x minus 1. So let us suppose I am dividing both of these polynomial by the actual division. Not using the remainder theorem right now, I am dividing both of them with the actual division. So as we can know that x raised to the power 4 plus x cube minus 2x square plus of x plus of 1 can be divided as, first of all, we have to arrange them in the descending order of their exponents. So they are already arranged. So we have to divide it with x minus 1. So let's just start dividing both of them. We have to divide the very first term of the dividend as well as the divisor. So the new term would be of the quotient is x cube. Now multiply x cube with all of these terms. It is x raised to the power 4 minus of x cube. Now we have to change the signs because we have to subtract both of them. But before subtracting, we are changing the signs, as this would be nothing but of minus sign, this would be of plus sign. So it is like they are getting cancelled with each other. So we have plus x cube, we have plus x cube. This would be nothing but plus of 2x cube minus of 2x square plus of x plus of 1. We are taking all the terms as it is. Now again, this is our new dividend. Again, we have to divide the very first term with the very first term. So it would be nothing but 2x square type. Now let's just multiply 2x square with all the terms. So it is 2x cube minus of 2 of x square. Now again we have to subtract both of these terms all together. So we are changing the sign first. So its sign would be minus, its sign would be plus now. So hence both of these terms get cancelled with each other. Again, both of these terms get cancelled with each other because this is minus 2x square, this is plus 2x square. Both of these terms get cancelled with each other. So at the end, what we are getting? We are getting the values as x plus of 1. Again, x and x, both of their degrees are same, so we can divide them until and unless the degree of the remainder is not less than the divisor. We have to repeat whole the process again and again. So x and x when get divided with each other, so we get the term as 1. So 1 will get multiplied with the divisor as x minus 1. So after changing the signs, it would be minus, it would be plus. So both of these terms get cancelled. Plus 1 and plus 1 is nothing but plus of 2. So the remainder is nothing but plus of 2. So at the end, the conclusion is the remainder that we are getting after the actual division of both of these polynomials is nothing but 2. But let us suppose we don't have to do the actual division and we are using now the remainder theorem. So as per the remainder theorem, for any linear polynomial x minus a, if x minus a is dividing the polynomial p of x, then the remainder would be of the type p of a. The remainder would be of the type p of a. It means we can see that this a in this particular linear polynomial is actually the value that we are substituting in the polynomial. So it means that if we are talking about this particular example, we have the linear polynomial as x minus 1. So let us suppose we are comparing these two polynomials all together. So by comparison, we do know that the value of a is nothing but 1. So substitute a as 1 in this particular polynomial. So we are substituting the polynomial px as x raised to the power 4x cube minus 2x square plus of x plus of 1. So substitute a as 1 in this particular polynomial. So we are substituting x as a, and a as nothing but 1. A as nothing but 1. So substitute the value 1 over here. So it would be like 1 raised to the power 4 plus 1 raised to the power 3 minus 2 1 raised to the power 2 plus of 1 plus of 1. Now solve it. 1 plus of 1 minus of 2 plus 1 plus of 1. So 1 plus 1 is obviously 2. 2 minus and 2 get cancelled with each other. So at the end what we are getting, plus 1 is nothing but 2. So at the end what is the remainder that we are getting? So we are getting the remainder as nothing but 2. It means that without the actual division of the two polynomials, we can say, we can find out the remainder of if we divide the two polynomials, then we can divide the remainder without the actual division in the formation of this using the remainder theorem. So remainder theorem is all about dividing out the remainder of the two polynomials without their actual multiplication, without their actual division. So this is all about the use of the remainder theorem in such type of the questions.